Good day, everyone. I'm Ethan, moderator for this webinar. Welcome everyone for today's webinar, Project Management for FDA-Mandated Activities. And I'd like to introduce our presenter for today, John E. Lincoln. John E. Lincoln is principal of J. E. Lincoln and Associates LLC. I would now like to hand over the floor to one of the best speakers of our area. Over to you, John.
Okay, thank you. And welcome to all in this discussion on project management for FDA-mandated activities. So we'll be covering project management tools, the three key ones, and then we'll be going into how we use those tools on certain common type of FDA-regulated activities. So there's an advantage for project management. This discussion is not for a certification. Basically, this is a tool for non-project managers. So these are tools that are very useful. We'll talk about how you start with a project. We're going to talk about work breakdown instruction. We'll talk about the three key project management tools, the Gantt chart, the CPM chart, and the PERT chart. And we'll talk about various simple construction techniques. We'll talk about which tools are useful and where. So when you do project management, you develop a system, you're developing a repeatable process. You start working in your project, you start working with your team members and the stakeholders, then you start getting maybe some additional areas you have to add in. Usually that's what happens. Now, whenever I'm dealing with a project, almost 100% of the time I'll do a flow chart. Here's an example of a very simple flow chart. Now here's a cause and effect diagram. When you're working on a project, you're going to break down the project into steps. And so my goal is to be able to quickly implement it, quickly explain it, be intuitive in reading it, and so on. So the work breakdown is usually the starting point. You're listing all your milestones and tasks from start to finish by reverse engineering from the end point. So now you want to start considering what are the critical structure elements? What are the key activities that need to be taking place? Breaking down the project elements. Now, the less you know about a project, the more you want to have discrete deliverables. So once you have the idea of the various inputs, then you develop your Gantt chart or your schedule. You have a Gantt chart, and that's basically broken down into milestones, tasks, and timelines, and responsibilities. The CPM chart, which is a critical path method, it's a network diagram which has nodes and lines, paths, and arcs. The calculation of another network diagram, the PERT chart, is a little harder. So let's look at the Gantt chart. I'll just go ahead here a minute. Here's the Gantt chart. We'll go back and visit this a minute or two. You notice there's a horizontal row. There starts with a milestone or tasks on the left-hand side. Then you have a description of that task. Then you have a timeline for that task. Then you have a responsibility for carrying out that task, whether it be a function or a person. And then you may have some comments, maybe the deliverable. So the Gantt chart is very simple. It's intuitive. It's easy to learn. You can develop it on typewriters. I used manual ledgers years ago. So here's an example of a Gantt chart. Now the next method is a critical path method. Now you notice here it was developed by DuPont Chemistry in 1957 for managing major chemical plant projects. So it's designed for large projects. There's an example. So you want to do your work breakdown instruction. That's the individual activities. So here again, when you're dealing with activity, each activity on node or on line, you determine what's the earliest start time this activity could start. So here again, we have the activities on node, and actually we have the time frame on node as well. The last chart we want to talk about is the PERT chart, the Program Evaluation and Review Technique chart. Now this was developed for another complex project, the 1950s for the U.S. Navy Polaris Submarine Development Project. The same thing as all three charts, you have to identify specific activities, milestones, tasks, etc. So here's the difference between the CPM and the PERT chart. And if a critical path is not obvious, then you determine things like what's the earliest start time for this, what's the earliest finish time, some of the methodology, and just using these times to work through the list. So here's a case of the PERT chart. Now, I like to have a dashboard if I have a lot of different projects. So what are the uses of these tools, project management? With design control, whether you're dealing with design control 820.30 or design and development planning, ISO 13485 7.3, you're talking about the same 10 elements in both. Agile has to be cautioned with the fact that you have to have defined processes, at least a certain minimum of that. You have to have documentation to prove you did comply with the GMPs, so that flies in the face of the GMPs. The tools that are very useful in Agile is iteration. Now, product development, the design control principles were defined in this chart that was circulated by Kim Troutman in the 1990s, in 96, 97, when design control was being implemented in the United States. So as we mentioned, here's the design control requirements we just mentioned. Incidentally, a member of the review team has to have no vested interest in the outcome. Usually that's QA. You have to involve regulatory affairs if you have a 510K or a PMA or a de novo or an IDE requirement. Volume planning to gear up production, what type of production equipment you need for throughput and so on. Your design output, the final documents at least, as well as the interim deliverables to get to the final documents. And here per the FDA, the company defines what is a device design input and what is design output, involvement of QA and RA in the submission of to the FDA, and also setting up your various QC testing of incoming raw materials, work in process, components, finished goods, etc. Now 14971, if you're doing a risk management file. Now if risk analysis you have to do with every new project, every new product, and every major change. Here they're laid out. Here's an example of software, the V model. Now with software documentation, you have to follow a guidance document if you're submitting something for FDA review. Now for a 510K, this lends itself to project management too. There's 21 requirements for a traditional 510K. There's also a special and abbreviated 510Ks. Class 3 summary and certification only if it applies to a Class 3 510K device. Now, the purpose of a 510K is to prove that your device is similar to a product already out in the marketplace, so the FDA has an idea of the issues of safety and efficacy that your product would bring because it's similar to a device out there. Here's an example of a typewriter generated Gantt chart or an old dot printer, so how simple they are to prepare. So some of the tools that we'd be using in project management is reverse engineering, flow charts, cause and effect diagrams, past data, templates for repeat activities, industry resources, peer group information that's non-classified. Just principles here that should be adhered to and incorporated into project management, like the voice of the customer. And we talked about various examples of tools that you could use the Gantt chart with, projects, design control. So that concludes my portion of this discussion.
That was the great session, and thank you everyone for participating. And we are going to conclude the session now, and you all may disconnect now. You all have a great day ahead. Bye-bye. Take care.
Yes, thank you.